one of the initial lectures we had learnt about queues, just basics about queues. So in which we had learned that a queue is a data structure that follows the principle of FIFO, that is first in, first out. That means whichever element is inserted first, that will be taken out first, that will be deleted first. So there are two ends in a queue, front and rear. So always remember, an element is always removed from the front and a new element is always inserted from rear, right? Okay, so here I'm going to give you an example. So we are, as per algorithm, we assume that the subscript starts from 1. So if the value of front and rear both is 0 and 0, that is an indication that your queue is empty. Front is 0, rear is 0. So that means queue is empty. Now this is my queue with the size 5. So I'm going to insert, I want to insert the very first element. So what I will do is I will increment the value of, I will set the value of front by 1 and I will set the value of rear also 1. So this is the new value, which could be anything. Suppose it is 25. Now, because we can insert only from the rear, right? So what I will do is I want to insert another element. So what I would do is I will keep the value of front as 1, but what I will do is I will make the value of rear 2. That means I will be incrementing the value of rear by 1. So this is my new element. Okay, again I want to insert a new element. So as per the rule of queues, I will have to increment the value of rear by 1. So it will become 3. And after that, what I will do is I will insert the new element, whatever it is. Suppose it is 125. Let's insert another element, make the value of rear as 4. So this is it, right? So let's I have been inserting the elements. Let's delete an element also. So as you know, we are supposed to delete the element only from the front. So what I will be doing is I will be deleting this element, and after that the value of front will be incremented by 1, and what will happen to the value of rear? It won't be affected at all. It will remain at 4, right? So again, what I am going to do is I am going to delete another element. So again, because now the value of front is 2, so I will go to the element which is at subscript number 2. I will delete it. I will increment the value of front by 1 because deletion has taken place. And as far as the value of rear is concerned, that will remain intact. That will be 4 only. And it will go on like this. Let's insert another element. Now I am going to insert. So what I will do is, because insertion takes place only from the rear, I will increment the value of rear by 1. It will become 5. Then I will insert the new element at the rear. So it is 88. And the value of front will remain intact. That will be only at 3. Now, next thing is going to be very interesting. Now what I am going to do is I want to insert the new element. Because the size of the array that is representing the queue is 5, I cannot say that queue is full. Why? Because there are still 2 elements which are empty. The place for them is for 2 elements is empty. So now, interestingly, what will happen is I will make the value of rear as 1 and the new element will be inserted here. Okay, so don't ever think that value of rear should always be bigger than value of front. It is not true. Now you can see that the current scenario is value of front is 3 and that of rear is 1, right? So again, let us insert a new element. So as per the rule, I will increment the value of rear by 1. That will become 2. It will remain at, the value of front will remain at 3. Okay, so This is the new element, whatever it is. Okay, now very important point. Now the important point here now is the value of front is equal to rear plus 1. Listen carefully. Value of front is 3, value of rear is 2. So value of front is equal to rear plus 1. Now note it down. Always remember, when the value of front is equal to rear plus 1, that is an indication that Q is full. Now if you want to insert a new element, that will result into overflow error, right? Now, so always remember this situation: when the value of front is equal to rear plus 1, the Q is full and overflow error is bound to take place. Now, what can be the other situation? Other situation can be, let's start from the beginning. So what I'm going to do is, let's start from the beginning. I'm going to delete these elements and let's assume that Q is totally empty. So I want to insert a new element. So as you know, as per the rule, what I will do is I will make the value of front 1 and that of rear also 1. Now Q is not empty. There is one element and this is it, which could be anything. Now again, I want to insert a new element. So of course I will increment the value of rear by 2. Whatever value I insert, suppose 34 again. But as far as the value of front is concerned, that will remain intact. Again, I want to insert a new value. So I will have to increment the value of rear by 1. So value of front will not be changed. Again, I will increment the value of rear by 1 because I want to insert yet another element. So this is 1. So let it be any element. Okay. So this is going to be my last element. Okay. Now the Q is full. Now in the previous example, I have told you that when the value of front is equal to rear plus 1, the Q is full. Now what is the other condition? Other condition is when the value of front is equal to 1 and that of rear is 5. Then also the Q is full. So you can check it out yourself. I have given you the full examples. There are two conditions when your Q is full. One is when value of front is equal to rear plus 1, and second when value of front is 1 and that of rear is 5. 5 means the size of the array. In this case, the size of the array happens to be 5. So whatever you can call it n. So okay, so this is how we can insert and delete in a queue. So now suppose I'm going to delete the elements. So let's see. Now suppose I want to delete the element. So of course deletion will take place only from the front. So the value of front will become front plus 1. It will become 2. As far as value of rear is concerned, that will remain unchanged. Again, I want to delete the element. It is okay. So it is 3. And to remain 5. Again delete it. Size is 5. 4. Value of rear will remain the same. Now I am going to delete the last element also, right? So now see what has happened is the value of front is equal to rear. When the value of front is equal to rear, that means we have only a one element, right? Now what I am going to so I have deleted all the elements. So now what I am going to do is I will be deleting the last element also. When I will be deleting the last element also, the value of front will become 0 and value of rear will also become 0. Now again, this is an indication that the queue is now empty. There is no element left in the queue. So if the user tries to delete any value now from the queue, it will be called underflow error, right? So always remember, when there is only one element left in the queue, the value of front is equal to value of rear. So what I am going to do is, when I will delete the last element, see carefully. Again, let's come to this point. Suppose this was the last value, right? And this is the situation. I don't remember what was the last value earlier, but that doesn't matter. Suppose it was 34. So in that case, what was the scenario was the value of front was 5 and value of rear was also 5. Now I am going to delete this. When I am going to delete this, of course, the value of front will become 0 and value of rear will also become 0. As I have been telling you, in the algorithm, I am assuming that the subscript starts from 1. That means front being 0 and rear being 0, that is an indication that now queue is empty. So again, I repeat it, when value of front is equal to value of front is equal to value of rear, that is an indication there is only one element. And when that element will be deleted, both the values of front and rear, that they will be becoming 0 and 0. So that means the queue is now empty.